So it's Tuesday, and if you can hear me over the farm machinery which is outside, being in a remote rural location, something we do get is farm machinery. Now this is coming for repair from an end user, and it's immaculate. Considering that's 38 years old, Harvard H410, and I've gone to the trouble of printing off a suitable service manual, not the Harvard service manual. We never had the Harvard service manual. We have the Alba, which is the same radio. All the time I've been talking, you've been looking at an out of focus meter. Sorry about that. So we've opened it up. So on the service manual here, it clearly says 12 volts. Speaker's 16 ohms. And the power output is 2 watts. And the minimum acceptable is 1.8 watts. You look at 650 milliamp power consumption with a maximum of 750. And this is, here comes the nitty gritty, because they're not the best receivers in the world by a very long way. The sensitivity is supposed to be 0.5 microvolts for 10 decibel cyanide. But 1.2 microvolts for 10 decibel cyanide is acceptable limit. They have the meter set for 50 microvolts for S9, but the industry standard is 100. So I don't like that, because it makes it look more sensitive than it really is. It's pretty deaf by any standard. So if they had the meter set to 50 microvolts, it makes it look more sensitive than if it was set to 100 microvolts. See how they cheat the system? There's a good description. This is a photocopy of a photocopy of a photocopy, and then scanned. So we've got all the alignment, how to set the test equipment up, and we've got a really ropey circuit diagram, and we've got some layouts, and I've had a T12 before now. So basically, what are we looking at? To do transmit, we're going to be adjusting so VR1 is deviation. VR1. So the one next to the little audio IC, that one is deviation. What else do we need to know? It is yes. They want you to bypass the loading coil for doing the power. So you can't. So you've got to go in from the socket there. You can't go in. So you've got the loading coil there, transformer 1, which we'll do for field strength at the end. And this coaxial cable, which goes to the socket there, is presented before that coil. Otherwise you'd end up tuning the radio to the aerial, which would be bizarre. So it's T2, T3, T4 and T5. So T2, 3, 4, 5. 2, 3, 4, 5. No idea what that little preset is. Somebody once asked me what the correct position is for the high-low power switch here. And this radio has been presented with it in the down position, so presumably that is the high power mode. And I'm going to write on this service manual because I don't know which is high and low power, it doesn't say. So I will write on that for future reference. So what we can connect it up, that's fair enough. I'm going to have to go and find one of those adapters because otherwise we're going to have a very, very short video because I can't repair it without the adapter. Right, well, I didn't find an adapter, so I've had to make a lead up, and that's not ideal because I don't want to incur losses, which could happen, but I'll be able to tell from the results. I've ordered more adapters, but that doesn't help me today. I don't want to not do this job today. So we'll plug our test set into that adapter. And that into the radio. And then we'll find the bench crocodile clips. And we'll make sure the power supply is running at 12 volts. And not at its normal 13.8. Switch on the power supply. That'll do. So we've got the red wire to the top, the black wire to the bottom. Let's just make sure that that looks feasible. It does. I don't always believe wire colours. You know what the big faff's going to be, don't you? And that's setting up the test instruments for receive onto the speaker, because there's no extension speaker socket. So that board's going to have to come out. We're going to have to clip across the speaker, and that is such a big pain. Okay, so let's go into picture in picture, and we'll look at what happens next. We'll switch it on. It was last on channel 25. Pop that onto 20. Can't say I'm getting any receive. It could be a dirty switch. Okay, so let's fingers crossed. There we go. 3-watt range, and I've got no transmit. Oh, I have. So we've got about where my connector goes in. The socket there is a bit dirty. Well, it's spot on, isn't it? It's actually doing 2.5 watts, so it's more than it's supposed to be. Well, we're not going to turn it down, but we're going to make sure. I'll make sure with the spectrum analyzer that it's actually. In fact, I'll put that on ready because I can see that the coils aren't quite where they should be. So I think we've had the Phantom Twiddler turning this up. I'm going to go over to a different power supply because I want to see how many milliamps this is drawing. So we'll just pause the video while I do that. Okay, so we're now on a different power supply because I need to be able to see what it's drawing. It's drawing 580 milliamps. And that's within spec. Good. Okay, so we'll do that coil for peak. that for peak, that for peak, and we've got a broken one. So we have peak, we've got 2.3 watts and we're drawing 590 milliamps, so that's well within spec. So that's good, and the customer can breathe a bit more easily that the thing is actually transmitting. So we were worried about the high-low power switch, so I'm going to flick that switch and we have 300 milliwatts. Wonder what that preset does. That preset adjusts low power. There's a tagged in preset I've not seen before. You see it kind of bodged on. Turns out it's low power. So let's go on to high power. Yeah, 2.3 watts. So that's good. Oh, I'm very pleased about that. So let's see if we can see what the, whoops, try and pick the radio up, what the meter's reading. It's reading 2.5, which is what you'd expect it to read for that amount. But I will just look where the adjustment is for that, had we needed to do it. So why is there no mention of that? Well, we'll do deviation. Now these have an electret condenser mic, which I think is in the bottom. To be honest, that looks right. We'll just do a whistle test. Wallow, yep, that's spot on. Had we needed to adjust it, it's VR2, which is there. So that sorted that out. So is it on frequency is the next question. Should be 27,79125. It's a bit low, and it's a bit lower than I would like. So the trimmer for that is the nice metal one just there. Well, it's a bit vicious. I think that's about as good as we're going to get, just slightly high, 2829. Okay, so we'll go over to the spectrum analyzer and we'll just see if there's anything nasty on there. I think it's position 5. It is. So press auto. So with myself in transmit, Nothing nasty up there. Nothing nasty down there. Oh, good. Well, I think that's covered the transmitter. So next we will put the receive frequency into the signal generator of 2779125. So we'll move the camera now onto the oscilloscope. There we go. And we'll see what the yes. We've now got to take the board out of the housing. This is the faff. I wonder if we can hear the receiver at all. We can. Pause the video. Right, so I've connected up the positive. I'm hoping we don't have to connect up the negative. You know what? We looks like we do. Oh, so the black wire is the positive. And the yellow wire, the red wire is the negative, and the black wire is the positive, just like you'd expect. So as ever, we're going to put 100 microvolts on the signal generator, and then we're going to adjust the detector for maximum output. My boss at Nottingham Radio would have said maximum smoke. So which is the detector likely to be? Does it have one? Or has it done some other way? 7 and 8. It doesn't use that technique. Forget about that. I'll shut up and go quiet. So we actually want the cyanide meter. We'll adjust that till we get about 4 dB, so we can see our adjustments easily. I'll just check they are 7 and 8 before plunging in. Yeah. Very slight improvement there. And the more significant improvement there. So drop the attenuator to go to 4 decibels. Do that again. So we do have a gain there. Now I'm going to have to read the sign ad here and now, because once I put this back together, we can't get into the speaker to make the check. I'll write on the back of the manual. So we'll put 20 dB, 12 dB and 10 dB, which is what they quote. Remember they said 0.5 to something like 1.2. So we'll, just for the laugh, just for continuity, we'll do 20 dB. I mean, not all radios can do it at all 20, but this can, and it's 2.7 microvolts. So although it's a double conversion superhet, it's a very simple one, and it's got a lot of things missing that a normal one would have. So don't expect these are quite a bleed over box, but then they're not intended to be used as a base station. So for 12 dB we've got 0.85. For 10 dB, which is what they're quoting, it's 0.7. So if we go back, it says the receiver's 0.5 and the limit spec is 1.2. So we're well within the limit spec. So it's a good example. So we now need to set the squelch, and the squelch is where these are really let down. It's atrocious. Let's turn the squelch to full. Oh dear, we're not getting anywhere. I'll see if I can see it on the really poor circuit diagram. Anyway, we'll disconnect from. I'll disconnect from the speaker. We'll put the radio back together because everything else can now be done with the radio board back in position. As a precaution, I'll take the power off. I'd hate to short out a customer's radio. I don't always mind if it's mine. Not that one, it's that one. I'm not going to be tight with these until we know they've all gone in the right position and aren't any wires trapped underneath. Tell you what we will write on here though, on the diagram. Oh yeah, oh VR2, yeah VR2, it's the VR2. So that it is a squelch, that one. But you know, don't hold your breath, because the squelch circuit on these is atrocious. Again, it's a handheld. You know, it shouldn't matter. So it's. I'll make a note of that. It's squelch, S meter, deviation, and on this one we've got low power. So on switch 7, the bottom position is high and the top position is low. That leaves one screw to put in, which is the one which is the biggest fat, because it's got that meter clip to hold that little meter in position. So you need to get the screw and the meter clip Not often you come across one of these where all the mounting pillars haven't died a death years ago. No, that's not gone in right. So we'll just back that off. You know what, I've now put it in back to front. I think I'll go home and give up. Oh, I am at home. But all that faff, it was worth it, because we did improve that receiver. We did, you know, so definitely improved it. Right, let's look at that. Oh, it's in. Good. Right, I'll switch the power back on. Yep, that's the best position. It's about 3 microvolts. I mean, how wishy-washy is that? Okay, so now with the signal generator set to 100 microvolts, let's just look at where the S meter is. Especially if I don't press the transmit button. So we know that's the S meter. There we go, that's set. That's it. So all that's left for us to do is to actually set the field strength. So what selection of field strength meters have we got? VHF, UHF, ham 1, that won't do. what's this one? That doesn't do field strength. There's one on the windowsill. That does field strength. If it works. Right. So what we're going to do is we're going to unplug my aerial adapter. We're going to pull up the telescopic aerial. And I says to the customer, don't even contemplate sending it in if the aerial isn't intact. I'm going to try not to clonk the camera. And of course this needs to be fully extended, which it is. So I'm going to now put a random bit of wire, because this has long since lost its little aerial they came with, and we'll see whether we can do field strength. So this needs to be, this needs to be switched to field strength. That's reading a whole load of nothing, so perhaps the meter doesn't work. That could be why it's on the windowsill, because I can't remember why it's there. Okay, well we'll have a rummage round till we find a field strength meter. Okay, we're going to cheat. I don't know where the field strength meter is. We've got quite a new CRT one, which is pretty cheap. I can find the SWR meter on its own, but I can't find the CRT field strength meter. I'll have to order another one of those. As I've said before, we've got building work about to happen here, and has been happening in the past. And there's 70-something boxes of 18-litre size, very useful boxes gone in storage. Of very useful things. And so what I'm going to do is what I'm going to adjust, because you won't see both the meter I don't think and the adjustment, was the coil just there, which is the antenna loading coil. Let's see whether we can move that Russian meter into view as well. This is our Russian RF voltmeter. I've just put a bit of wire on the end of it. When I key up, you can see we've got a deflection. So I'm just going to make sure, and I'm going to then adjust this. Just make sure that's in view. Just there. So without touching anything, I'll go up a scale. Whoops, that's the core out. That's definitely not the right position. I'll put this down because what I'm doing is as I'm holding it, I'm kind of waving it. It needs to be absolutely still. So let's go again. So we hit a peak and then it's gone back down. peak. It's about there. That's it. So that's where we'll have it. And that means that the maximum possible efficiency of the aerial has been achieved. Okay, so now we need to put the radio together. So we'll carefully put down the telescopic aerial. Oh, I've hit my own cobwebs up there. I didn't even know there were any cobwebs up there. And then that clicks together. Then the lid goes on. I'll just put some cleaner down there. I think the issues with him saying it wasn't transmitting were actually down to the internal switch. Right, better put the screw back. We're doing on-the-air test tonight from the workbench like we do. Somehow I'm going to have to power that up. Let's make sure we can do that. So we know we've got the negative there. We'll probably have to rig something up so I can clip onto the power there. Whatever we do, we have to be careful because these were like chocolate box plastic even when they were new. Just turn the radio off. I don't like bouncing the power. I've been able to force a bit of wire down the back of the contact there. There we go. For those of you who know, you can switch the display on and off. You've got a channel 9 switch. One on a Roger. So there we have it, the H410T from 1981. I'm sure that's going to work okay. So it's 2.4 watts and better cyanide than it said in the manual. So I think we've done all right with that. And I'm sure the customer is going to be pleased with his recent purchase off eBay. Thank you for watching.